Hi and Assalamualaikum. My name is Muhammad Faiz, and today I would like to present to you about my final year project entitled Sentiment Analysis on Gaming Device using Support Vector Machine and Naive Bias via Data Visualization. First and foremost, let me explain to you what is the project scope of the study. The analysis was conducted on the latest gaming device, which is PlayStation 5 or PS5. Next, the analysis was focusing on three types of classifications. The classifications are positive, negative, and neutral. In this project, support vector machine and naive bias were used. And lastly, the data was scraped from the Twitter. As I mentioned before, the proposed title is Sentiment Analysis on Gaming Device using Support Vector Machine and Naive Bias via Data Visualization. Let's move on to the part 1, elevator pitch. The first thing is background study. Sentiment analysis is an analysis that determines whether data is positive, negative, or neutral. While gaming console is an electronic or computer device that produces a video signal or a visual image to display a video game, and the gaming console can be either permanent or handheld. So, in this project, I chose PlayStation 5. The first problem statement is difficulties in finding overall customer satisfaction towards PS5. The second problem statement is unachieved customer expectation towards PS5. And the last problem statement is slow marketing strategy of the gaming device company. Next is objective. First is to design a sentiment analysis of the PS5 gaming device based on Twitter data reviewed by PS5 gamers or PS5 sellers. Second is to develop a sentiment analysis model on a PS5 gaming device based on Twitter review using supervised machine learning algorithm. And the last one is to test the accuracy of the sentiment analysis. Moving on to the second part, technical presentation. Solutions. The solution is sentiment analysis using support vector machine and naive bias. Support vector machine create and utilize the hyperplane. Support vectors are the data points nearest to the hyperplane. Hyperplane separates the data into classes. And the maximum the margin, the better the support vector machine works. Naive bias works on conditional probability, and the formula is it predicts membership probabilities for each class, such as the probability that given record or data point belongs to a particular class. It assumes that all the features are unrelated to each other, and a bunch of counts is needed. Hence, the highest score from the hypothesis testing produces the correct class. Methodology. Support vector classifier and naive bias are used. The project programming language are Python and Excel Visual Basic for Applications (VBA). Jupyter Notebook and Google Colab and Microsoft Excel are used, and the models are trained on a laptop. So this is the workflow of my project, and there are 6 steps altogether. This is the output after I have done scraping data and pre-processing of data. In pre-processing of data, I put extra works which are translating and correcting words in Excel. These are some important codes in vectorizing the data and training the models. For vectorizing the data, I use the FIDF vectorizer, and the outcome is 764 times 1997 dimension. And for training the models, at first I train the models without using any parameter, and the outcome is quite low. After that, I insert some range of parameter for both classifier, and for naive bias, I got the best parameter is alpha equal to 1.0, while the best parameter for support vector classifier is the C is equal to 100 and the kernel is linear. So for the performance evaluation step will be discussed later in the slide, and we move to the last steps in the workflow, which is deployment of model. I have deployed the trained model into two different sentiment classifier, or can be called as text classifier. For the first one, you just put the text you want, such as good, and then you just click me, and then it will produce the sentiment. Same goes to the classifier naive bias. You just put another words such as bad, and then this classifier also will produce the sentiment. And another one, sentiment classifier, I have created it by using by the sentiment package, so without training any models. So to use it, you just simply enter the words or text you want, such as bad day, and check sentiment, and it will produce the percentage for each classes and the overall sentence rated as negative. Next is result and discussion. This is the class distribution represented in bar graph. Positive tweets score the highest value compared to negative and neutral tweets. Negative tweets are actually with the lowest value among these three categories. So as a conclusion, most of the tweets are positive. So next is the scores obtained from prediction after training the models. Support vector classifier produces the lowest average scores without optimal parameter, while multinomial naive bias produces the highest average scores with optimal parameter. And I can say that with optimal parameter, it will produce better results. In this slide, the table shows the result from doing the accuracy testing. And multinomial naive bias has the highest average accuracy, which is 68.62%, while support vector classifier average accuracy is 56.21, and it is the lowest one. Multinomial naive bias classified most number of test data, which is 105 out of 153. This is another testing that I have done by inserting 7 different words into each classifier, and the result is by the sentiment classifiers classify all words correctly, while support vector sentiment classifier and naive bias sentiment classifier misclassified same count of the words. Hence, support vector sentiment classifier and naive bias sentiment classifier succeed to classify 61% of the words correctly. As a conclusion, this model succeed to analyze and visualize the sentiment of the tweets. The most accurate classifier is multinomial naive bias with the accuracy of 68.62%. There are 3 text classifiers created, and the text classifiers are quite good. For future works, I suggest to analyze and compare the performance of more machine learning classifiers, such as maximum entropy, and deploy the trained classifier into a real-time model. In addition, visualize sentiment of real-time tweets can be considered as a good recommendation. And lastly, add more design and criteria into the graphical user interface. That's all from me. Thank you.